Howdy everybody in YouTube land. What we have in front of us today is a Hewlett-Packard E3610A DC power supply. Now this one came off the free pile at the local Hamfest swap meet, Stone Mountain Hamfest. And I figured, well, a friend of mine is looking for one, I'll grab it for him and fix it, etc., whatever. But because this was on a free pile, chances are there's something wrong with it. So I got it all plugged in and yeah, there's something wrong with it. No power. Now, I do notice that the lights flicker a little bit when I turn this on. So this is drawing current and it's a linear power supply. So there's going to be apparent losses in the transformer anyways. And I don't want to get into the theory of that. But there is something wrong with the front end. It does not energize. There's some weird issue going on with that. Now, I want to see, though, if it's putting out any power whatsoever. I don't think it is, but we should double check to make sure. So, actually there is. There's 17 volts on the output. This thing only goes to 15, so there is something catastrophically wrong with this unit. Alright, so let's crack this thing apart and figure out what we got going on. So, I'm trying to think of how this comes apart. It looks like someone's already tried. Well, we shall see. Yeah, I had a feeling someone's been in here before because it just kind of fell apart as I was trying to take it apart. So we have a PF series capacitor, which these are known junk, and as I can see, there's no surprises there. Oh, looks like we got some piss in here. What is that one? A 4700 at 25, which I don't have. Oh, well, that's nice. We have a what's left of a oh, yeah, I don't know what that is, but we're going to have to locate that. I don't even know where that came from. Oh, I see. Looks like someone's had a go at trying to fix this, and they gave up on it. We got more leaking capacitors over here. So, yeah, well, yeah, 1993. That makes a lot of sense now. That's why we have capacitor pissing everywhere, so... And this wasn't even plugged in, which explains why it doesn't turn on. And why we have 17 volts on the output. Alright, well. So, where do we go from here? Well, first off, we know the capacitors need replaced. This is a 10,000 at 50, which we're probably going to have to change as well. But, before we even think about recapping this thing, we need to take a look at these transistors to make sure none of those had failed. We got to figure out exactly what this even was, because I don't even know. And someone tried to solder it or something. I don't even know where that ferrite bead even went. So yeah, you can see all the capacitor damage here in the resistor network. So that's all it is. This thing is just suffering from leaky capacitor syndrome. Well, we're going to have to get this thing completely apart, and we're going to have to wash this board and clean it up because it is disgusting. But that explains why it does not work. Yeah, October of 93. Yep. That makes a lot of sense. Other than that, though, spared no expense. We have Bourne's potentiometer rotary encoders. These are rotary encoders. Actually, no, it's a multi-turn pot. Never mind. So, that's cool. This thing's entirely analog. That is so cool. But, yep, that's why it doesn't work. Caps. Is anyone surprised? I'm certainly not. Well, fortunately, this circuit is not that complicated. So I found the schematic. Now, this is the Agilent version of it, which is what HB evolved into. And everything, I mean, there has been a few component changes over the years. Like, they don't use this particular transistor anymore, for example, which is like, what is this? An MM5007. They've changed that. They don't use that one anymore. Now they use a 2N something another. I got to see if I can locate one. And that's going to be based off of the properties that I Google up and see if there's a modern retrofit for that. Anything they make now is going to be a TO220 style, regardless. But that is the series pass driver transistors for these two outputs, which, by the way, test fine. But yeah, the circuit is not that complicated, so at least we have something to go off of. What is, however, that complicated is trying to get all of this off, because I got to wash this board. It's nasty. And in order to do that effectively, transformers got to come off. Power switch has to come out. All of these wires and cables and things have to come out. So I got to make sure to make a note where they all go. So, not going to be fun. But also, we need to change these resistors because of how badly corroded they are. So they're going to have to go. But fortunately, the service manual actually has all of that stuff spec'd out. So I know exactly where, like, oh, Q2, which this is the 4036, which is what they've subbed it with, right? And then we need R, what do we need here? We need R3, 4, and 5. So if I look up R3, 4, and 5, which is here, well, this is what they are. Half watt, thin film, 5%, 1%, you know, we got everything here. So we can go on Mauser and we can order the correct parts to replace those. I tested the fuses are good. The bridge rectifiers, on the other hand, are to be determined. They're probably not very good. But, let's see, CR9 and CR13. If we look here again, CR9 and 13 is diode, bridge, 100 volt, 1 amp, which I can probably find. Not a problem. So Q2 does not have a sub. No, I'm not surprised. Alright, well, you get the gist. So we got to pull all this apart and get this thing cleaned, because it's not going to do any favors having this cap goo sit everywhere. Wow, this thing was nasty to remove. Crap. Well, at least now I can wash it, but trying to pull all the pads off. I lost a pad right there, unfortunately, but that's not a big deal because it's soldered up here. So, transformers off. The transistors had to come out. Everything had to come out to get this board completely out of the circuit. So, I can set all of this aside and focus purely on this board. Tell you, that is gross. Capacitor P everywhere. That one's really bad. I'm thinking that CR9 is going to have to be replaced for sure, because it's toast. Got some missing copper down here on this voltage regulator, so you see someone marked FB on Q2, which, you know, ferrite bead, which makes sense because that's where it goes. Right onto R43, which, or not 43, R3, which is, yeah. Alright, well, anyways, yeah, we're going to have to scrub-a-dub-dub this thing. There's a little rectifier under there, but got all the caps off. This one doesn't appear to be bad, but we're going to change it anyways. We've only got like 1, 2, 3, 4, 5 caps. We got some of these little piddly ones, but they're one mic at 50 volt, which I actually have them on hand, so I'm not worried about that. Alright, so now that we have all the parts gathered up to work on this thing, now since this thing is a power supply and it's a piece of precision test equipment that, quite frankly, is critical, because if you're powering something off of this thing, you have a specific voltage and current set. It's not like it's, you know, you're dealing with an RF signal generator where it doesn't have to be 100% perfect, but a power supply has to be as stable as it possibly can be, especially when you're doing experimenting and testing. So because of that, I'm going through here and I'm cleaning up all of the damaged tracks, and I'm just going to tin them up and seal them a little bit. But also, because we have some corroded resistors over here, I decided to order some new replacements. So we have those now, and we should have all the other capacitors. And funnily enough, this particular transistor, which is completely gone, by the way, just totally gone, they actually make them brand new. I was able to buy a brand new one of those transistors, so we'll get that replaced as well. So anyways, I'm just going through, get it all cleaned up. There is a broken trace here, but it looks like it only goes to this test point. It doesn't go anywhere else that I can see, but I will patch that up just to make sure I don't have any issues, because I've got to go through the service manual and recalibrate it. I also ordered a new potentiometer to replace that one. Even though I don't think there's an issue with it, you can tell it's kind of got surrounded with cap juice. So I got to replace that. And then I'm going to replace this diode bridge, which I have some extras here. So we'll get that replaced as well. And it should, in theory, come good again. So let me finish getting this stuff ground off, and I will sit you up on the other camera angle, and we'll do a time lapse of putting the parts on here. So I've got all the new parts in here, the new resistors. Now I couldn't, some of these resistors I can't get, like that one in the middle. I wanted to get them all matching, but that's the best I could do with the percentages I needed. So those are replaced now. I replaced this potentiometer, and I tried to adjust this as close as I could to the original. So one side is adjusted, the other side is slightly different than the other one because the carbon track between the two is probably slightly different. So I'm gonna likely need to calibrate this anyways, but I wanted to get it close. So that's in there, the bridge rectifier's in there, all the new caps are in there. There was a broken trace here that I had to patch off the transistor. I got the ferrite bead where it's supposed to go. I have a patch wire over here. I also had to run another patch wire through this hole. You can't see it, but there's a via right there that comes through to this side. So I had to patch wire that because it was broken. And I had to check because I was concerned about a connection between this capacitor, which runs to the positive output to the bridge rectifier. So I metered that out from here and here, and it's fine. It's still connected. But if not, I can just run a jumper wire on the bottom side between here and here if I have to. So that's not a big deal. So now it's time to start getting this thing back together. And I'm going to get some new thermal compound for those transistors and start sandwiching this whole thing back together. So it's loosely put back together. So now it's a matter of, is it going to work or is it not going to work and go into a ball of flames? But, well, we shall see. So here we go. First time turning it on camera. Well, we have something. Question is, do we actually have something? Hey, my voltage adjustment's working. Amperage set. Well, I mean, let's do a half amp. It's maximum it's gonna go. It says it's 1 volt. Supposedly goes up to 15. So let's see. Do we have 1 volt on the output? No, we shall see here. We do, and that is really accurate. 2.02 volts. Yeah, that's what we got. Let's do... Oh, let me get this zoomed out a bit. Most important voltage out of all of it's like this one right here. Well, it's close. So what we need to do is we need to get this thing on like a load tester. Just zoom this thing all the way up. I like the precision multi-turn pot. Apparently this says it only goes to 15 volts, but we're getting up to 17, so yeah, we're working. All right, well, let's do our usual 5 volts. Oh boy, it's like a very low response time. Ugh, stupid plugs. All right, well, let me get the load tester out and see what it does with the load tester. All right, load tester is connected, so here we go. Let's set you, let's see, 1 amp, which is not going to work. Let's start at 100 milliamps on. So it shows we're pulling a 1/2 amp, which is not right. Actually, it might have been this thing. So 100 milliamps, this is off a tiny bit. 2 amp, 2.2, 0.3, 0.4, 0.5, which is what we have. We're set at 0.5. Yeah, see? 1/2 amp. Yeah. It's working. We're working the way it's supposed to. So let's set the current to, we're going to set you up to 1 amp. See if it'll do 1 amp. We're going to start drawing into the milliamps here. Oh, we're starting to trip. I love how it's doing this, which is in sync with this. You can't see it on the camera because of the scan read, but it's literally in sync with this. It's kind of funny. So we're literally starting to trip at the 0.16 milliamp mark. Yeah, see? Now we're tripped. So I can like put it right here. Yeah, it is working. It's working like it's supposed to. We'll go back down to 1 amp. Alright, so here's what we're going to do. We're going to wind you up to... max you all the way out. It should go a maximum of 3 amps. Well, 3.14. Irony. Alright. We're pulling 3 amps. 3.1 amps. Alright, now we've tripped. So, it says it's doing the rated power. It is doing the rated power, so that's cool. Now, we have drop across this wire, which is why we only get 4.8 there. That's why we have a sensor probe there, because the sensor probe is designed to connect right at the input. So, because this has parasitic RLC. So, anyways, it seems to be working fine. I'm going to read the manual and see if there's a way to make sure the calibration set, because it is slightly off. But other than that, it is working. Alrighty then, so I just went through and done the calibration procedure. So we have 0.35. So 3.15 is 10 times, which makes sense because we're supposed to have an 0.1 resistor, and it says 0.315 for this model, and we have to adjust R20, which is the potentiometer that we replaced. So we have 3.15, so when I set the current, it should be the same, and it is. Everything's good. Now, if we go to low current mode, we fall to 2.10, and then if we look here, 2.10. So remember, we're 10 times because this is simulating that 0.1 ohm resistor. So we're good. Everything's fine. We are functional. So I can turn off my simulated load, bring the voltage back down. And we're good. Everything should... Ooh, it's too far. We'll run about 12 volts. Turn the power on. So we're running about 12 volts. Current is turned all the way up at 3.15, give or take. So it's really, really, really close. Now, I'd have to put an ammeter in between here to know for sure, because who knows if this is even accurate. Because, I mean, this is one of them 6-letter Chinese wonder muffins. So I would trust an HP more than I would that thing. But it's calibrated and everything is good to go now. So I can go ahead and wrap this project up. Relatively simple fixed, just a little involved. Needed some resistors replaced, needed the potentiometer, and all of these caps changed, and we're fully functional. So there we go. All good. And there we go. That is a fully functional, restored benchtop power supply. And it's a nice power supply. These don't bring in a lot of money. They're just general run-of-the-mill single rail power supplies, but they're really good for powering breadboards or experiments or even troubleshooting stuff. If you're missing a laptop power adapter, you could run a laptop off of this thing. I kind of do that all the time with that one. It's a handy little power supply for doing little odds and ends. So there's all the bag of parts there replaced. There's other stuff that I got rid of, but anyway, so that's it for this one. I'm going to go ahead and kick it down the road to a friend of mine for his Christmas present. So if you enjoyed this video, don't forget to hit the like and subscribe and all of that fun stuff. If you have a comment, please feel free to leave one. Until next time, guys, thank you for watching.